Hi, in this video I am going to explain how I have implemented the Pascal's triangle program with the iteration method without any recursion and without using memoization. It is a basic iteration method. So this is the program I have written here. So to explain this, when we are running the program will start from the line public static void main string args, and the first line is pascitr, the class name ob equals to new pascitr. That means that object will be created of this class, and suppose the user input we have taken is int n equals to 5. So the user input is 5, and then we are continuing with the actual program. So I have taken this nested loop, int I equals to 0 and I is less than n I plus plus. So this will count the rows of the this Pascal's triangle. So this will start from 0 to n minus 1. So the rows will be 0, 1, 2, 3, 4, yes, 4 till 4. The row number will be 0, 1, 2, 3, 4, and the column will also start from 0, 0, 1, 2, 3, 4. So when the value of I is 0, and this particular for loop is for the spacing purpose, so that for printing the first one there will be 1, 2, 4 spaces, 1, 2, 3, 4. Then there will be 3 spaces, then there will be 2 spaces, and then there will be 1 spaces, and this one will be like side at the left. So this for loop is for the spaces, and j starts from 1 and j ends till n minus I. So as I increases, the number of spaces also decreases, because when I is equals to 0, then the space will continue from 1 to 5 minus 0. Then when the I is equals to 1, the space will continue from 1 to 5 minus 1, that is 4. So 1, 2, 3, 4, only 4 spaces. In this way the spaces are getting calculated, and this part is refers to the column of this pattern, and I refers to the row of this pattern. So to print this one, this is at 0th row and 0th column. So when this condition comes, that I equals to 0 and j equals to 0, then the position value, like I have implemented binomial theorem to print this Pascal's triangle. So each and every element of binomial theorem refers to this formula NCR, which means that n factorial divided by n minus r factorial into r factorial. So I have implemented this formula to find out the values of these values. So when row equals to 0 and column equals to 0, the position value or NCR will be the factorial of the row divided by the factorial of the column into factorial of this n minus r, or row minus column. And this factorial function is implemented over here. So this factorial will basically take a number, and in this factorial variable I have just calculated the factorial using this for loop, and then returned the factorial. So the factorial value of the factorial will be calculated here in this for loop, and then it will go from this line to these 3 lines. Like first ob dot fact of the row will be calculated, then it will come here. Then ob dot fact of j will be calculated here, and then the value will come here, and then the ob dot fact of I minus j will be calculated here, and then it will come here. So in this way, each and every values of this row and this column will be calculated. For example, suppose this is 0th row, this is 0th row and 0th column. So the factorial will be ob dot fact of 0 divided by ob dot fact of 0 into ob dot fact of 0, which is equals to 1. Suppose we want to calculate this value, so this will be 0 1 1 0 1. So this will be 1th row and 1th column, this 2. So ob of fact of 1 divided by ob of fact of 1 into ob dot fact of 0. So this will result to the answer 2. In this way, for the whole Pascal's triangle, we are calculating the values. So this is basically the basic iteration method to generate the pattern of Pascal's. Then coming towards the Pascal's triangle generation with recursion technique. So the simple method of implementing recursion technique is, I have implemented this logic basically. Suppose we are calculating the value of 4. So we have to first find the value of its previous row and previous column, that is 1, and previous row and the same column. Like suppose the column number is 2 for 4, then the column number of 3 is also 2. Like this is one column number 1, this is column number 2, this is column number 3, this is column number 4, this is column number 1, this is column number 2, this is column number 3. So when we want to find the value of 4, we have to first find the value of the previous row and previous column. So we have to first find the value of 2 minus 1, which is equals to 1, and then we have to add the value with the same column number of the previous row. In this way I have implemented. So then to find the value of 1, we have to first find this number and this imaginary number, suppose. So when this condition comes, so this is the base condition I have taken. So if this condition comes, then 0 will be returned here, and when this condition comes, 1 will be returned here. So 0 plus 1 equals to 1. In this way this value comes. Then to find 1, we have to find this imaginary value and this 1, and this imaginary value will be 0, and 0 plus 1 equals to 1. So this value will come. In this way it will continue here. And when coming to this part, suppose we have to find the value of 3. So to find 3, we have to find this 1 and then this 2. To find this 2, we have to find this 1 and this 1. In this way we can find the value of this 4. So this is the basic logic of Pascal's triangle. So I have implemented here. So this is the part from the previous iteration program only. So we have created the object, we have taken a user input. Suppose this is a user input, we have taken 5 as the input. Then basically what are we doing? We are finding the values from here. So to find 1, we need this value and this value. So there is a nested for loop. This for loop is for spacing purpose, and this for loop finds out the column, and this for loop finds out the rows. This for loop is for row, this for loop is for column. So when I equals to 1 and j equals to 1, so this refers to this one, as the row is 1 and the column is also 1. So I am doing what? I am basically passing the row and column to the Pascal recursion method. So what is happening? The 1 and 1 goes to this R and C, and then it checks that C is equals to 0 or C equals to 1 or not. That means that suppose this is the one I am finding, so it will check that whether the C is 0 or C is 1, the column, whether the previous rows C is 0 or the previous row C is 1. If so, then the value of C will be returned. So suppose I want to let me do it in a clean place. Suppose I want to find the value of this one, so I will check the value of the previous row's column 0 and then the previous row's column 1. So when the previous row's so when the previous row's column is 0, then we will return 0. So 0 will be returned from here. And when the previous row's column is 1, then 1 will be returned here. So this 1 will be returned here. As all the values of this diagonal are 1, that is why we have to implement the base condition like this. I don't know I can explain it properly, but I am trying to do that. Okay. So, and suppose for this part, suppose we are finding the value of this one. So I have to find the, suppose the column number for 1 is 3. So I have to find that the column number of previous row will be 1, 2 or 3, or same column number basically. So the same column number will return 0 in this case, and we have to also check the left part. So this will return 1. So I have implemented this here. If the C equals to R plus 1, that means return 0. So this is the condition, that if the previous column 1, 2, this is R plus 1, that means 1, 2, R, 2 is R, and then 3. So this is the column. If C equals to R plus 1, 3, then it will return 0. And if R equals to 0, that means for the top one, for this top one, if R equals to 0, that means the previous numbers, this will also return 0. So 0 will be returned from here and 0 will be returned from here. I think I am making this a bit complicated, but I think you can understand. I am trying my best to make you understand. So basically to find the value of the previous row, I have done R minus 1 and C minus 1 plus R minus 1 and C. In this way we are basically traversing in this method. So in this way I have done the recursion, and for the memoization I have taken a map which can hold a string key of type string and a value of type integer. So why did I take the string as a key? So my logic was that because I have to store both R or row and column, because I have to store both r and row and column for the key. So I have basically implemented it like this: the row number will be r comma c. This will be the string, like a value, suppose r is 1 and column is suppose 5. So this will be the string, this will be the key, this will be the key for this string. So with this key I want to find the value of this integer basically. So this will be my cache. So the program is same as the recursion, just I have implemented this if cache dot contains key, and this part that I have implemented, this part does means this part makes this format of string. So r will be, suppose r is 1 and c is 5, so the string will be formed 1 comma 5. So this will be my key and I will find the value of this key. So the contains key function will find the value corresponding to this key in cache map. So if there is a value corresponding to this key in cache, then it will return the value of this key. This will return the value of this key basically with cache.get method. And the previous thing is same, like I have done this passcalc of r minus 1 comma c minus 1 plus passcalc of r minus 1 comma c in the result. I have stored it in result, and suppose if the result is very new, then we are just putting the value of the row and column as key, and result I am putting the result in the cache with the key r comma c. So I am just using the row and column as my key to find the integer value which is mapped in the cache, and the rest of the program is absolutely same as the past recursion method. So in this way I have done the memoization. So if you want to see the code, I have uploaded in the GitHub, and I am also mentioning you the link in the description in YouTube video. You can check it out there. Thank you very much. I hope I made this clear. If no, I have tried my best. I have to make this clear. Thank you very much.